Hello everybody, my name is Miss Physics. I'm a physics teacher and today I'm going to solve a question for you. The question is about magnetic fields and moving charges in a magnetic field. The paper that I'm going to solve for you today is, the question that I'm going to solve for you today is question number 9 from paper 4.1 from May-June 2021 session. The question starts by asking what is meant by a magnetic field, and I think you should all know by now, if you are studying physics, A-level physics and magnetic fields, is that a magnetic field is a region of space where a moving charged particle experiences a force. So, a region of space where a moving charged particle experiences a force. Or you can also define the magnetic field by saying that the magnetic field is a region of space where a current carrying conductor experiences a force. But I like the moving charged particle in a magnetic field experiences a force. Now, we have a rectangular piece of aluminum foil which is situated in a uniform magnetic field of flux density B as shown in figure 9.1. It says the magnetic field is normal to the phase PQRS of the foil. Electrons, each of charge minus Q, enter the foil at right angles to the phase PQTV. On figure 9.1, you have to shade the face of the foil on which electrons initially accumulate. Now, if you want to determine the phase on which the electrons will initially accumulate, you have to use Fleming's left-hand rule. Fleming's left-hand rule will give you the direction on which the electrons will be forced to move. So, the thumb, the direction of the force, the first finger is the direction of the magnetic flux density, the magnetic field lines, and the second finger the direction of the moving particles. Now, because you have electrons, remember the electrons move in the opposite direction of the electric current, so your second finger should point in the opposite direction to the movement of the electron. So the first finger pointing downwards and the second finger pointing from right to left, and you will see that your thumb points towards you, it points towards phase PVWS, and this is the phase on which the electrons initially accumulate. Now, the next question, it asks you to explain why electrons do not continuously accumulate on the phase you have shaded. Now, as the electrons will start to accumulate towards phase PVWS, between this phase and the opposite phase QTR and another letter over there, between these two phases an electric field will be set up. So the electrons will also start to experience an electric force. At some point, the electric force will be equal to the magnetic force, so the electrons will stop accumulating. So let's write down. Initially, as the electrons move towards phase PVWS, an electric field will be set up between the opposite phases. when the electric force, I call it Fe, is equal to the magnetic force, the electrons will stop accumulating. Go to part 2 for the second part of this question. Thank you for watching.